We have seen how a multi-stack can be formulated by using a single array. We will be defining a lengthy array and we will be considering the ends of that array, the left end and the right end, or the beginning end and the ending end. If we place these stacks in this manner, then the left stack will be increasing from left to right and the second stack increasing from right to left. So when the top ends of both these stacks are placed in such a way that their indexes are next to each other, we can say that the stack is full. Incidentally, the name of those stacks will be same because an array cannot have two names. So this long array represents stack 1 as well as stack 2. For reference, we are naming the first few indices as stack 1 and the last few indices as stack 2. So for implementing this, we have to define a structure of the following format. Structure of a multi-stack looks something like this. I told you that even if we are considering two stacks, it will be identified by the same name. It's an array. So we have to define an array with ample capacity. Let it be max. So with max as the size of the array, we are declaring the stack as item according to this definition. So item is the name of the stack. Whether it is stack 1 or stack 2, they are defined by item. So item will be having some indices belonging to the left side of this array as stack 1 and indices belonging to the right side of this array as stack 2. Then for the overflow condition, we have to check whether elements present in stack 1 and the elements of stack 2 when put together should not exceed the maximum limit. That is, if there are 15 elements or spaces declared for an array named item, this item will be representing two stacks, virtually two stacks, and stack 1 can store at most 15 elements with no elements in stack 2, or stack 2 can store 15 elements with no elements in stack 1, or put together say x elements in stack 1 plus y elements in stack 2 put together can hold at most 15 elements if max value of max is 15. Hope it's clear to you. So for that we will be including a member named as count. So value of count should never exceed max. For example, if we declare max as 15, then its indices will be from 0 to 14, but the number of elements in it will be 15. So the value of max is the maximum number of elements present in the array item. So for that we will be using a member named count. Whenever we add an element to one of the stack, we have to increment count. If we add an element to the second stack also, we have to increment the same count, so that it never exceeds max. Whenever it reaches max, we can assume that further addition result in overflow condition. So bear this in mind. Count is used for checking overflow condition. Then we will come across underflow condition. We have seen that in previous cases when we use single array for single stack, whenever the value of top is -1, it is termed as empty stack. And during the status of empty stack, if we try to pop up one element, it results in underflow condition. So we will be considering two tops here because we are virtually indicating or including two stacks into the same array towards the left end and towards the right end. So they have to be manipulated using two tops, one for the left array portion and the other for the right array portion. So whenever left is -1, we know that the indices of this array, big array, ranges from 0 to max -1 if max is the maximum limit. So 0 to max -1 are valid indices for this array. I will make it clear with an example. If the size of the array, that is max, is 6, it means that that array can hold at the maximum of 6 elements, and these 6 elements will be having indices 0, 1, 2, 3, 4 and 5. So the first index is 0 and the last index is 5 when max is 6. So here last index is max -1, that is 6 minus 1, 5. So the valid indices of this array will be 0, 1, 2, etc. up to 5 only if there are 6 elements. So the value just before 0 is -1 and value just after 5 is 6. -1 and 6 are invalid indices if the size of the array is 5. Am I right? If the size of the array is 6, the invalid indices just outside the valid indices are -1 and 6. If the size of the array is 10, then the invalid indices are -1 and 10, because valid indices will be only from 0 to 9. So these invalid values will be considered as underflow condition for the values of the two tops. -1 is the underflow condition for one stack and max will be the underflow condition for the other stack, because -1 and max are invalid indices for the array. We can consider only from 0 to max -1. Therefore, any value outside this range 0 to max -1 will be invalid. As we are differing only with a single value, with a value of 1, we can take only 0 minus 1 or max -1 plus 1 to have the closest invalid indices. those values will be taken into consideration for checking of underflow condition in both of these stacks. So the members in the multi-stack structure will be name of the array with maximum limit, and this corresponds to the elements of both the stacks. Elements put together should never be going beyond max. And when we are treating two stacks, we should have two top positions. Let it be top 1 and top 2. And count will be the number of elements, total number of elements present in the left side of the stack array as well as the right side of the array. And when it reaches or equals the value of max, we can say that all the spaces allocated in item will be full, which reaches the overflow condition. And see, this is used for referring to the stack, which stack we are operating on. If there are only two values, it can take only 1 or 2. If it is towards the left side, we say that it is stack 1. If it is towards the right side, we say that it is stack 2. So it can take either value 1 or value 2. So based on the value of Sn only, we will be performing the push and pop operations. The push pop operations are very similar to what we have seen in single stack operations, but there is a slight difference when we go to the other side of the array. Other side means we usually used to have operations from the front end of the array. We never go to the back end. But here, when we are considering multi-stack, for one stack we are beginning from the back end also. So the indices varies in different ways in both the ends. When the indices are taken into consideration for the left array, the indices changes from 0, 1, 2, 3, etc. But when it comes to the other end of the array, the indices changes from max minus 1, next one is max minus 2, max minus 3, etc. That is, the change in indices or the values of indices decrement when we consider the right hand side and increment when we consider the left hand side. Normal condition was incrementing the index value during push operation. That remains same in the case of left stack, but in the case of right stack, we should decrement the index while performing push operation. This has to be there in your mind. This change should be there in your mind. What is that? Whenever we are adding values to the left portion of the list, we will be incrementing index values. Then we will be adding the value. But when we go to the right end of the list, we should decrement the index value. Then we have to add the element. In both these cases, we have to increment this count value. Whenever we add an element to either the left side or the right side of the list, we have to increment the count, because if it is left or right, the element will be inducted into the array. That means number of elements in the array is incremented by 1.